this yesterday. I'm going to go over them today to see if you got them right. Number 1, find the missing side of each triangle. Which type of side is missing? A leg. A leg can be plugged in for what? A or B. I'm just going to choose to plug it in for A, which they're saying to call it X. Not that that really matters. You could have left it A squared. Then that means the other leg is a length of 3 units, so I'll plug it in for B and square it. And then the hypotenuse, which is always across from the 90-degree angle, is 5. And then square it. Because remember, the Pythagorean theorem is A squared plus B squared equals C squared. Now I just simplify. That becomes X squared plus 9 equals 25. Now to get X by itself, I subtract the 9. And I end up with X squared equals 16. To cancel out a squared, the inverse operation is square root. And so X equals the square root of 16, which is 4. Number 2, same type of problem, but this time the missing side is the hypotenuse. So this time we do not know the C squared, but they're calling C X, so X squared. We know the A is either 8 or 6, it doesn't matter, and the B is the other one. That then will become 64 plus 36. When you add those together, you get 100. And now to get X by itself, you have to remove the squared by square rooting it. And then whatever you do to one side, you do to the other. And the square root of 100 is 10. All right, number 3, you can figure out the answer by looking back at some previous questions. If you had a right triangle with leg lengths of 8 and 6, and you ended up with 10 for the hypotenuse, and now you have a triangle with 10 as the hypotenuse and a leg of 8, the other leg must be 6. Same thing with number 4. If you had a right triangle and it had a hypotenuse of 5 and a leg of 3, and then you found the other leg to be 4, and now you have a right triangle with legs of 3 and 4, the hypotenuse has to be 5. All right, number 5. Yes? Okay. State if each triangle is a right triangle. So, for a triangle to be a right triangle, your A squared plus your B squared must equal your C squared. Well, for this particular triangle, what number could be plugged in for A or B? 6 and 8 are your A and B, correct? Because don't those appear to be at the right angle, which we're trying to prove? We're not sure if it's a right angle, but these would appear to make the right angle. So I'm going to plug in 6 for the A and square it, 8 for the B and square it, and then the hypotenuse always goes into the C and square it. 6 squared becomes 36, 8 squared becomes 64, and 11 squared becomes 121. And then what is 36 plus 64? 100. Does 100 equal 121? No, which means no, this is not a right triangle. There's no right angle there. It may be like a little more, a little less, like 80-something degrees or 90-something degrees, but it's not exactly 90. Yes? They probably, right. They make them appear to be right triangles, but you have to do the math to prove that it's not. Yes, it is misleading. The picture's misleading. You'll see a lot of that next year in geometry, and it'll say on the paper that the diagram may not be like true to size. You know what I mean? Okay, so this one, it appears that the right angle would be over here, which means the legs are 3 and 4. So that would be your A and your B. Order doesn't matter there. Your C would be across from the right angle, which would be that 5, and then square it. 3 squared is 9, 4 squared is 16, 5 squared is 25, 9 plus 16 is 25, so you end up with a true statement, which means yes, this one is a right triangle. That is a right angle up there. Okay, number 7. Find the missing side of each triangle. So this time we're back to finding a missing side. What type of side is missing? No, the leg. Okay? I am going to just use X for the A. Shh, guys, there's too much talking. Plus, what would the B be? Okay, let me make a little state. Now we simplify. This will become x squared. This will become, and what is 16 squared? Now to solve for x, what do we do? And so now we have x squared equals, and now to solve for x, we have to get rid of that. Square root to cancel it out, which means square root this side, square root of 31. Okay, number 8. This time you're given both of your legs. So it doesn't matter which one you choose to place in the A or which one goes in the B, just one of each, equals your hypotenuse, which they're calling x squared. 4 squared is 16. 6 squared is, what is 16 plus 36? 52. Now, what do we need to do to get x by itself? Square root it, square root it, and so I don't see the square root of 52, so what must we do? Right, factor tree it. What are factors of 52? Okay, and then 26 will break down into a, and then that 2's prime, so it just drops. Now what do we do? Circle, kill, kick out, and then the one that wasn't circled goes back inside. 2 squared of 13, which is C. Okay, turn over to the back. We're almost done. Number 9, we're looking for the missing leg. So that means the square root of 82 has to go where? A or B, right? So if I put the square root of 82 in the place of A, and then I square it, because that's what Pythagorean theorem does. And then I put the other leg, which they're calling x, in the place of B and square it. And then equal it to the hypotenuse squared. What can I do to simplify this? Right. Yeah, all of y'all, okay, hold on. Right. Square root and a square cancel each other out, leaving just 82. And what does 16 squared become? Now to solve for x, what do we do? And so now you have x squared equals, I got 174, right? Yeah, you added instead of subtracting it. But 82 was already positive, so you guys subtract it. Okay, now to get rid of this, you square root it. Now, I, assumed this was the answer, but I did check. Like, I typed this in and got the decimal version of it, and then I typed both of those in just to make sure one of them wasn't in simplest form. Do y'all know what I mean by that? Like, I did verify that A and B were not the simplified version of the square root of 174. And I did that by just typing it in and looking at their decimals. Well, they are both the same answer, but one's in simplest form. Yeah, it did say simplest form. See? Simplest radical form. Okay. Number 10. Number 10. We are given both legs, so I'm going to use 2 to go into A. I'm going to put the square root of 13 in the B. And then the hypotenuse, they're calling x, is unknown. Now, just like before, a square root and a squared cancel each other out. So this will basically become 4 plus 13, right? And then that just becomes, and now to solve for x, we And so x equals the square root of 17, which cannot be simplified because it's prime. All right, number 11. State if each triangle is a right triangle. So just like before, this time there's just radicals in the problem. We have to know that a squared plus b squared equals c squared. Well, what could I possibly plug in for the a? Okay. And if I choose to put 5 in for the a, what must go in for the b? Right. Now, when you square this one, it does not simply just cancel out the radical because there's a 4 in the front. If you have a number on the outside, you must put all of it in parentheses showing that all of this is squared. And then it will equal the hypotenuse, which is 11 squared. Now, everybody pick up your calculator and type in the left side. What does the right side equal? Right, so now everybody type in the left side and see what it is. What does this side become? You typed something wrong. 121. Okay, let me show you how it should look typed in. 5 squared. Okay. Let me show you what it's doing, guys. Look. The 4 gets squared, and what happens when you square the 4? A 16. And then, yes, at that point, the radical and the squared will cancel each other out, but then you got a 6, and 16 times 6 is 96, and then when you add that to the 25 that was there, that's how you get 121. Since they're equal, yes, this is a right triangle. Yes, Sion? No, you can't just cancel out the 2 with the square root because of that number on the outside. That's why you got to put it in parentheses showing that all of that is squared and not just that part. Okay, number 12. It appears to me that what numbers are the legs? Right, the square root of 123 and 10. So I'm going to put those in for A and B and square them. And then that means C would be that square root of 222 squared. Now, since there's no number on the outside of the radical, this radical will cancel out with the squared, leaving just 123 plus 100 is what that will become, equals 222. Okay? That becomes 223, which is not equal to 222. So no, this one's not a right triangle. All right, last 3. Find the area of each triangle. Round intermediate values to the nearest tenth and use the rounded values to calculate the next value. Round your final answer to the nearest tenth. Now, we're not going to do this step. We're just going to leave ours in the square root, but we will round the final answer to the nearest tenth. Since we're not going to round the square root off, our answers are going to be a teeny bit off, but you'll still know the right answer. All right, number 13. First of all, how do you find the area of a triangle? Correct. You take 1/2 of the base times the height. Do we have either the base or the height for this triangle? Correct. The height is 8. Now, we also have the hypotenuse, which is not part of this formula, but can be useful in finding the base. How can we use it to find the base? Right, Pythagorean theorem. So we'll use 8 for the a squared, and then that could be our b, which is unknown, and square it equals 9 squared. That then becomes a 64 plus b squared equals 81. Now what do I do? And so now I have b squared equals what? And now to solve for b, what do? Square root it, and so b equals the square root of 17, and isn't that b also your base of the triangle? And now when you type all of that in, what do you get? And it's like 16.49, which we would call 16.5, but the reason they didn't is because they didn't type in the square root of 17 for the base. They went ahead and changed that to a decimal, which kind of changes your answer at the end. But it's okay. It's close enough that you know the answer. All right, number 14. We're trying to find the area of this triangle. So we do 1/2 of the base and the height. Which one do we have? which is the base. The height is currently unknown. But since we also have the hypotenuse and this is a right triangle, we can use Pythagorean theorem to find that missing side, which will be your height. This becomes a squared plus 25 equals 64. Now what do we do? And so now a squared equals, and now to solve for a, and so a equals the square root of 39, which is also your height of your triangle. And now when you type all of that in, what do you get? 15.5. Well, it's a little off because they rounded. Like when they got to the square root of 39, they went ahead and gave that in decimal form and rounded it, which will change it at the end. But okay, Marcus, what's the square root of 39? Type in square root of 39, tell me what you get. Okay, what is it? 6.2 what? Okay, so it'll stay 6.2. Now type that in and tell me what you get. See, that's why the answer choices are a little different, because in the directions, it wants you to go ahead and change that to a decimal, but we're just leaving it. But it's still close enough that you know the right answer. Okay, last one, number 15. What's different about this one? There's two triangles, but we're trying to find the area of the entire triangle. But like Naya said, we don't know the base at all. Okay, we do know the height is what? 9. So to find the entire base, pay attention. Don't you have to know the base of this triangle and the base of this triangle? So let's start with the smaller triangle on the right. What is its A value? 9. Its base, its B value is unknown. That's what we're trying to figure out. And its C value is, that becomes 81 plus B squared equals 121. Now what do we do? And so now B squared equals, and now to solve for B, what do we do? And so B equals the square root of 40. So this little part of the base is the square root of 40. Now how do we find this other part of the base? Right, you do Pythagorean theorem again using 9 for the A. The B is still unknown, but now our hypotenuse for this triangle is 21, and then square it. That will become 81 plus B squared equals what? And now what do we do? And so B squared equals, and now to solve for B, and B will stay the square root of 360. So isn't the base of this triangle square root of 360 and square root of 40? What does and mean we need to do? Add. So in your calculator, add the square root of 360 plus the square root of 40. What's the square root of 360 plus the square root of 40? 25.3. Now do 1/2 times 25.3 times 9 to find the overall area. So A. Marcus, it should... Did you not get 25.3?